Hi, I'm Dr. Memari again. I'm sure by this time, with so many experiments, you already know my last name, you know what I'm going to talk about, but I will tell you, I'm performing the experiment so you can have access to collect data for the experiment and be able to complete the data sheet to turn in your data sheet to your professor as your assignment. If your professor is me or someone else, might hold a short Blackboard Collaborate meeting and talk more about the theory and how they want things to be done. But by doing this experiment here, I'm going to make it possible for you to have data, and based on the data, you are going to complete your data sheet and turn in. Let's talk about a little bit about the theory, what the experiment is, just enough to make sense out of what we are doing in this experiment. Experiment is Le Chatelier's principle or chemical equilibrium. Based on the Chatelier's principle, your reaction, first of all, it must be at equilibrium. How do we know the reaction is at equilibrium? When you see like double arrow reaction, this means the reaction is going to reactant can change the product can change back to reactant, and at one point the reaction is going to reach equilibrium. The rate of the forward reaction equals the rate of the reverse reaction. It doesn't mean that the reaction is going to stop, but the reaction is going back and forth with the same rate of the reaction. Based on the Le Chatelier's principle, if you have a system at equilibrium and you apply any pressure to this system at equilibrium, the reaction is going to shift. The direction of the reaction can shift from reactant side to product or product to reactant, depends on what you have added or what has happened to the reaction mixture. Let's say your reaction is a endothermic reaction. If it's endothermic reaction, that means the heat is going to be on the reactant side, and if heat is on the reactant side as a reactant for endothermic reaction, you increase the temperature, that heat is going to go to the make the reaction to go to the product side because heat needs to be consumed. This is the challenging part of the experiment that I tell you. If you increase concentration of reactant, it's very obvious that it will go to the product side. But when you are applying heat to reaction at equilibrium that is endothermic, since the heat acts as one of the reactant, the reaction is going to shift to the product side. If it's exothermic reaction, heat would appear on the product side. Now, cooling it down is going to, taking away the heat is going to make the reaction to go forward. So it's best for you to write where the heat appears and then treat that as a reactant or product. For exothermic, heat appears on the product side. For endothermic, it appears in the reactant side. I'm going to perform the experiment for you to collect the data. When you are recording your observation, please don't just say that the yellow color changed to orange color. Everybody, kindergartner, would know the color change. But based on the color change, you should say if the reaction shifted to right side or shifted to the left side. Let's say if your reaction mixture is yellow color, and then you add like sulfuric acid, it changes to orange color. You can't just the yellow color change to orange color. Everyone would know that without being in 1046 class. But in 1046 class lab, you should say the H plus addition of the sulfuric acid or H plus, it disturbed the equilibrium, the reaction at the equilibrium, and the reaction shifted to form more product to cancel or to neutralize the pressure of addition of concentration of H plus. So be careful when you are when you are recording your observation, you would record it more scientifically. So it's going to help you to fill out your data sheet easier and better. There are few parts to experiment. I think there are just 4 or 5 experiments. You want to make sure to first to include the chemical reaction at equilibrium, then look at the changes that is going to happen. The Prelab, we're not working with the Prelab at this point. When you read the experiment, you can decide on the Prelab. But for the data sheet, we have for part A of the experiment, and then we're just going to continue with these experiments, like if you're going from chromate or chromate reaction at equilibrium. I'm going to stop the sharing of the document. I will use my lab manual as usual in order to perform the experiment. So I did not prepare everything prior, so I'm going to read the experiment. For part A is the chromate dichromate equilibrium. When you have your lab manual, you have your lab manual which you purchased from the vital source, and the experiment part A, it's saying using a test tube. So I'm just going to get my test tubes here. Please take a test tube, clean test tube, and add 1 milliliter of 0.1 potassium chromate. So we're just going to add 1 milliliter of potassium chromate. I have my goggles on, have to make sure. We're adding 1 milliliter. One milliliter of potassium chromate. And added 1 milliliter of potassium chromate into a clean test tube, and I want you to record the color. So with the white background, record the color. Okay. See, I'm trying to get you the best angle, so the color in the camera shows as the color that I have here. Okay, you can record the color. So record the color. This is just the potassium chromate. And to this, we're going to add H2SO4, 3 molar H2SO4, dropwise, and until you see the color change. So I'm adding H2SO4. See color change? Okay. Record the new color. This is after adding H2SO4. Okay. After adding H2SO4. New color. Then I want to add let me find a dropper and add sodium hydroxide. So 1 molar sodium hydroxide. So we're adding sodium hydroxide to the solution. Sodium hydroxide. We add sodium hydroxide. And because the concentration of H2SO4 was 3 molar and this is a 1 molar, it might take longer time, but eventually you will see the color change again. Okay. Record the new color. This is after addition of sodium hydroxide. So after addition of sodium hydroxide, record the new color. Okay, we are done with experiment 1. So this was experiment 1, or part A of the experiment. If you look at the balanced equation, you can make sense out of this. If I give you all the answers, then I think you don't have any work to do, and it's not good, and I don't like that, and I'm sure if someone else is teaching the lab is not going to like that you have all the answers and you just copy it down, because that's not the purpose of this remote learning. So you see the evidence of the reaction, you look at the balanced equation and see what is happening, and you record your observation. So we need hot water baths. I'm going to prepare the hot water bath. You discard the water already. Going to prepare hot water bath. Okay. We are going to add cobalt 2 chloride to 2 test tubes. Okay. Cobalt 2 chloride to 2 test tubes. Okay. About 2 droppers. It's going to be 1 milliliter. So I'm adding cobalt to both test tubes. Of 1 milliliter. Okay. I want you to record the color of cobalt 2 chloride. This is before adding anything. Okay? Before adding anything. Or before any changes. Then we are going to add HCl. And I hope that you understand, if I'm adding HCl, I'm basically adding Cl minus to the reaction mixture. So I'm adding the HCl. Going to take you to fume hood, so we can add the HCl inside the fume hood here. Concentrated dropwise to both tubes while stirring until we see some changes. Okay. So you record the color already. We are adding HCl. This HCl is not just adding H+, it's also adding the chloride. It's adding chloride ion. So it's good comparison to see what the color changes taking place by adding HCl, because I only added to one of the test tubes. So there is a color change there. I want you to record what is happening after adding HCl, and I'm going to add to the other test tube as well, HCl. Adding concentrated HCl. Okay. I want you to record your observation after adding HCl to both test tubes. Now, I'm going to take one of the test tubes only. So to one of the test tubes, I'm leaving one test tube in the test tube rack. Leave one of the test tube in test tube rack. To the other test tube, we are going to add deionized water. We are going to add deionized water. See, adding deionized water, if you again go back and check the reaction mixture, you can see that even adding water is not just going to go from dark color to light color because it's going to be diluted. It's actually changing color. Okay, and I'm going to add enough. And I want you to record the color, what's happening after adding H2O, deionized water. This is for part B of the experiment for cobalt equilibrium. Adding to test tube 1, we added water. Until no more color change, so we saw that everything has changed to the original pink color that we had. It went back from blue. So we are going to place the this solution now inside a hot water bath. We're going to place inside the hot water bath. And oh, sorry, I'm taking the camera to myself. Okay, I want you to see that there is a change in color happening in the test tube. Gradually, you see the top portion is blue, the bottom still is pink, but we are going to continue until no color change, no more color change is happening. So I'm going to bring the camera closer so you can see the color change. Color change is taking place in the test tube. See, sometimes just change in temperature, it can affect the equilibrium. It can shift to the right or to the left. Okay, record your color, record your observation after heating the test tube 1 in hot water bath, in boiling water. Record your observation, please. Record your observation. This is after heating up in the hot water, in hot water bath. Now, let's put it in the ice bath to see what happens if you place in ice. Made the ice water bath here. See the part that is already cold is turning color and is working its way up. So the color is changing. Just want to make sure that the whole test strip is in the ice water bath. And if it stays in the ice bath for a long time or long enough, everything is going to be changing color. When I was talking about exothermic, endothermic, like you lower the temperature, it changes to one side. You increase the temperature, it changes to the other side from the color of the reactant. And looking at the balance equations that you have, because it gives you the colors, we say if it's shifting to the right or to the left, and you can decide if this reaction is exothermic or endothermic type reaction. Heating it up, it changed to blue color. So if the product is blue color, that means heating up the reaction, it made it go to product side. Okay, placing in ice, it changes back to pink color. Going to let it stay for you to record the observation. Record your observation in the ice bath. This is filled with cobalt, and see what happens in cobalt. Okay. Now, we're done with part B. We are moving to part C of the experiment. That is for ammonium chloride. Ammonium chloride, going to find the test tube, a clean test tube. There are plenty of test tubes, but you need to find a clean test tube. Okay, that's the challenge now. Okay, clean test tube. Find a clean test tube, add 1 milliliter of ammonium chloride, saturated ammonium chloride. Okay. Saturated ammonium chloride. And we are going to place it in hot water, in boiling water. So saturated, there's no crystals in there, right? There's no crystals. We place in a hot water bath. We want to see what happens if we place the saturated ammonium chloride in hot water bath. Now you're supposed to stir it periodically. Okay. It says it's saturated, so. It turned a little cloudy, but no obvious change. So I wouldn't stop here. I'm going to continue heating, see what is actually happening. So it's clear and colorless solution, so nothing happened to it. Going to take it, cool it down, and place in the ice bath. So this is what your observation is going to be. Nothing happened. Is clear solution. Place in the ice bath. Okay. Looking for solid ammonium chloride, and it's not here, so I was looking for someone to help me with that. Okay. I have to wait for the solid ammonium chloride. So let me get the solid ammonium chloride. Can I please get solid ammonium chloride? Thank you. Brittany? Can you please grab solid ammonium chloride? Yes, it's the best. With the, I'm going to start with part D until we get the solid ammonium chloride. Go back to part C. I'm sorry for the interruption because we didn't have the solid ammonium chloride actually here. It worked. Okay, this is the ammonium chloride placed in ice bath. So ammonium chloride placed in the ice bath. So we're gonna take it back. We gotta finish the part C. So we have ammonium chloride in the ice bath form solid crystals, and when we place in the hot water, it changed to clear solution. So in the hot water bath, it changed to clear solution, and in the ice bath, you saw the precipitate. It formed crystals. So dissolving basically ammonium chloride in water, you can then decide based on the observation of these two different temperatures. You could say if this is like exothermic reaction or endothermic reaction. What happens when the ammonium chloride is in water is being heated? Would it dissolve better, or if it's cooled down, would dissolve better? If heat is needed for something to dissolve, the reaction is going to be considered to be endothermic reaction, as I said earlier. So we are done with part C of the experiment. I was just nervous because it didn't happen right away. But after I left it for a while and I went a couple times looking for solid ammonium chloride to make the solution again, good news was that it did form the crystals and it worked actually. So with the solid ammonium chloride, we're going to make this solution ourselves. It's going to try to dissolve the ammonium chloride, solid ammonium chloride in water. To test the thermometer, use the thermometer to test for temperature. Since you're not here to test the temperature, I'm just going to give you the difference in temperature. The temperature of the water, okay, so measuring the temperature of the water, deionized water, is 24 degrees Celsius, close to 25. 23.7 degrees Celsius. The temperature of the solution, 17.4. What does it mean when you try to dissolve ammonium chloride in water? It cools down, the temperature is lowered. What type of reaction is that? Is that exothermic or endothermic reaction? That's what you basically need to identify at this point. That should be your conclusion for this part of the experiment. for endothermic reaction or exothermic reaction, how heat or ice bath or hot water bath is going to affect the shifting of equilibrium. Part D of the experiment, that's the last part. Part D of the experiment, in a test tube, we are going to add deionized water, and we are going to make it half fill deionized water. Record your observation. Just the clear water with the test tube that is not so clear. Okay, much better. Different test tube. Record your observation. This is just the deionized water. And we are going to add sulfuric acid to this solution. Going to label so we know which one is which. Label a test tube for acid and one for base. Today I performed 3 experiments. I'm a little slow because I'm a little exhausted. Anyway, I have my test tube labeled acid and a test tube labeled base. I'm going to add H2SO4 to the acid and NaOH to the test tube labeled base. Just following the procedure. We are going to add the phenyl methyl orange indicator to 2 test tubes. This is your indicator. The indicator is called methyl orange. We want to know what happens to the color of methyl orange in acid and in base. Okay. So when we add to the acid, the color is red color in acid. And in base, the color is yellow color. Okay. This is the yellow color and base and acid. Record your observation. You can, if you have your data sheet open, you can record your observation. In the acid, red color and yellow color in base. Okay. Now, what's the purpose of this part of the experiment? It's trying to tell you how indicator, which is HIN, is going to be affected in acidic solution and in basic solution. So basically, the reaction at equilibrium is your HIN AQ that gives you H plus and IN minus. So when you add H plus, which way is going to go? And when you add NaOH, that's basically you are removing H plus. You are adding OH, and OH minus is going to react with H plus. It changes to water. Basically, you are removing H plus from your equilibrium. So you want to see what is the effect of adding H plus or adding OH minus to the color of the indicator. So basically in acidic solution means that you have extra H pluses. It should go to the color of the HIN, which is the red color, and in basic solution it would go to the IN minus. So you have to defend it based on the color of the indicator in acidic and basic. But you always know that in acidic solution and basic solution, indicator is going to have different color. But what's more important for you to know that equilibrium reaction for the color, and then for the equilibrium reaction, the color of the indicator in acidic solution and basic solution, how that equilibrium is going to translate to the color change based on concentration of H plus or lack of high concentration of H plus or removing of H plus from the equilibrium. 4 reactions only, but it's very important for you to know about the Le Chatelier principle, that any pressure, it can affect the reaction at the equilibrium. We don't need it anymore, and be able to write your observation, complete the data sheet, and turn in your assignment. There are some additional questions also for you to answer. Thank you, and I'm going to stop the recording here. End of experiment 4 for 1046 lab.